Good morning class, good morning to all. Today we will start chapter 1 force C part, that is uniform circular motion. So let's get started with uniform circular motion. So now we have to understand the term what is the meaning of uniform circular motion. So let's split this word uniform, circular and motion. Uniform means when a body cover equal distance in equal interval of time, that is called uniform, and that equal distance in equal interval of time occurs in a circular path or circular motion, that is actually a uniform circular motion. So here is the definition: when a particle moves with the constant speed in a circular path, its motion is called circular motion. Here we have to see one important thing is that when a particle is moved with the constant speed, it means that in a uniform circular motion, speed is constant. Whether velocity is changing or not, acceleration is changing or not, that we don't know. But in uniform circular motion, one thing is clear, that the speed is constant. Okay, so speed is constant in a uniform circular path, so it is called uniform circular motion. Now we have to see the direction of velocity at any instant in a circular path. For example, a car is moving in a circular path in anti-clockwise direction. So we want to find the velocity at some instant. Like at A point I want to check the velocity, at B, at C, at D. So now let's see how we will check the direction of velocity. So here if we will check at A point, so direction of velocity in the north direction. Now let's check the velocity, direction of velocity at B instant. So B instant we got the direction of velocity in the west. At C instant we got the direction in the south, and at the D instant we got the direction in the east. So what is the meaning of this? It means that in order to get the direction of velocity at any instant, we have to draw the tangent at that point. For example, if we want to check the velocity at this point, so let's draw the tangent at this point and you will get the velocity at that instant. So for a circular motion, to get the direction, you have to draw the tangent. So direction of motion is along the tangent drawn at that point of the circular path. Here note one thing, that at each and every point the direction is changing. Even though in a uniform circular motion, magnitude value is constant. For example, this car is moving with 10 km per hour speed. So this 10 km per hour is actually a magnitude. So magnitude wise this is constant. Magnitude wise this car is not changing their speed. But at each and every point, direction of motion is keeps on changing. At 8 point north, at B point we got west, at C point south, and D point east. So here it is concluded that magnitude in a uniform circular motion is constant, but direction keeps on changing. Now let's see the difference between the uniform circular motion and uniform linear motion. So here we are a uniform circular motion and here we have a uniform linear motion. So one thing is clear, even if it is a uniform circular motion or uniform linear motion, speed is constant. So we will not talk about speed. Speed is clear that in both case speed is constant. Now let's talk about the velocity. So now let's understand what is a velocity. Velocity is a scalar quantity or vector quantity. So velocity we have a vector quantity. What is the meaning of vector? Vector means it is depending upon both magnitude as well as direction. So here in a uniform linear motion, magnitude is same and direction is also same. It is moving in same direction here, so magnitude is same, direction is same. But in uniform circular motion, magnitude same. Why? Because it is a uniform circular motion, but direction is not same. So here direction is not same. It means that as velocity is a vector quantity, magnitude same but direction is not same. So that's why velocity is changing in a circular motion. So velocity is variable in a uniform circular motion, but in uniform linear motion velocity is constant. Okay, so this is the about the velocity. So now let's talk about the acceleration. If I'm talking about acceleration, what is acceleration? Acceleration is change in velocity. Acceleration formula is change in velocity over time. So whether a velocity is changing, in which case velocity is changing? In uniform circular motion velocity is changing. If in uniform circular motion velocity is changing, why velocity is changing? Because direction is changing. So velocity is changing because of direction, not because of the magnitude. So acceleration is produced in case of uniform circular motion, but in uniform linear motion acceleration is zero because velocity is not changing. So if you talk about the difference between the uniform circular motion and uniform linear motion, velocity is variable in uniform circular motion, but velocity is constant in uniform linear motion. Acceleration is not zero in uniform circular motion. Acceleration is zero in uniform linear motion. Clear? Next point we have, force is required to move a body in a circular motion. What is the meaning of this? Carefully see. In order to move the body in a circular motion, what is it, the circular motion? Circular motion magnitude is constant, but direction is keep on changing. As direction is keep on changing, a constant force is required to make this body in the variable direction. It means that we have to required or we have to apply a continuous force on a body so that the body will change its direction. So this force which is required to make the body in a circular motion, that is called centripetal force. We will see this concept now. So in case of centripetal force, the centripetal force is acting toward the center of the body, means acting toward a center of a circular path. So this is called centripetal force. Now let's see the definition. So what is a centripetal force? For example, this boy is rotating a marble with the help of rope attached to the marble with hand. So a force is required. This you have seen also in your daily life. You have seen that if you will apply the force, only then you are able to rotate the marble in a circular motion. Otherwise it will not rotate by itself. So you need a constant force. You have to apply a constant force on the marble. And in this case, what is a constant force? This rope is applying a constant force. You are applying force on the thread or a rope, and this rope is applying force on this body marble. So a continuous force is required. So what is a centripetal force? The force acting on a body. It is a force which is acting on a body which is moving in a circular path, and it is acting in a direction toward the center of circular path. It means that here the centripetal force is acting toward the center. Centripetal force signifies as F subscript C. So it is called centripetal force. So centripetal force is always acting toward the center of a circular motion. So again see what is centripetal force. It is a force required, or it is force acting on a body which is moving in a circular path, and their direction is toward the center of a circular path. So here I have to also add one more thing. If force is acting toward the center, we know that F is equals to ma. Okay, so here we acceleration, we are talking about now acceleration is not zero. That acceleration is called centripetal acceleration. So centripetal acceleration is having direction same as the force. It means centripetal acceleration is acting toward the center. So if I am talking about the circular motion, so here we have a centripetal acceleration. Okay, now here carefully see, at this point centripetal acceleration in this direction, at this point centripetal acceleration in this, at this, and last at this. It means that at each and every point centripetal acceleration direction is keep on changing. So centripetal acceleration is again a vector quantity. which depend upon magnitude as well as direction. So centripetal acceleration is depend upon magnitude as well as direction. Magnitude will not change. For example, magnitude is not changing, but direction is keep on changing. So that's why acceleration in a uniform circular motion is also changing because of change in direction. Next, we have to see some examples related to this. Means we know that for a uniform circular motion, centripetal force is required. Now we will take some examples of uniform circular motion, and there we will see which centripetal force is acting on the body. For example, electron is revolving around the nucleus. So here one force is acting. We have to see which type of force is this. So this is a positive charge, electron is having some negative charge. So positive and negative attract each other. So that attraction force is called electrostatic force of attraction. So in case of electron revolve around the nucleus, centripetal force name is called electrostatic force of attraction. Now carefully see this here. Here centripetal force is acting, but name of those centripetal force which is acting in this case is called electrostatic force of attraction. Now let's see another example. A moon is revolve around the earth. So as moon is revolve around the earth, there is attraction between the two masses, that is equals to F is equals to G m1 m2 by r square. What force is this? This is called gravitational force of attraction. So in case of moon moves around the earth or revolves around the earth, centripetal force acting here is gravitational force of attraction. Next we have earth is revolving around the sun. So as earth is revolving around the sun, which force is acting? Again this is having a two mass bodies. So here in this case centripetal force is again gravitational force of attraction. Next we have a person or a boy ties a marble or tie a stone with a thread or a rope. So here stone tied at one end of a string is whirled in a circular path. So which force is acting? Now carefully see, this boy applies a force in this direction. So this thread or this rope applies some force, okay, in this direction. So this force is called tension in the string. So here centripetal force in this case is a tension force in a string. So each and every case centripetal force name is different. At some places centripetal force is electrostatic force, gravitational force, tension force. So according to the nature, centripetal nature is keep on changing. Next we have centrifugal force. So now let's understand the concept of centrifugal force. Now first see the definition. A force assumed by an observer moving with the body to act on the body in the direction away from the center of circular path. It is called centrifugal force. So now let's understand what is the meaning of this. For example, a boy is rotating a marble or a stone with the thread. So this boy feels two forces on his hand. First, this boy feels a tension is produced in the string, and second force he is feeling that some force is acting on the ball which is taking this ball away from his hand. It means this boy feels that एक फोर्स लग रही है जो इस बॉडी को इससे दूर लेके जा रही है. It means that one force is acting on his hand to keep this ball away from him. So that force observed by this body which is in the circular motion of this body, means it is feeling this circular motion, that force is called centrifugal force. So now again understand the definition. A force assumed, it is not a real force, it is assumed by this person or by an observer who is moving with the body. Either it is moving with the body or it is feeling the motion, circular motion, and this forces act on the body in the direction away from the center. As tension is a centripetal force acting toward the center, centrifugal force is acting away from the center, okay, of the circular path. So it is called a centrifugal force. We will also see this with one more example. So next point we have, it is not a real force as it is observed by only, it is assumed by the observer who is rotating or who is moving in a circular motion with the body. So it is not a real force, it is a fictitious force. And one more point is that it is not a centrifugal force, is not a force of reaction of centripetal force. We know that according to Newton's third law, there is always a action and reaction pair. To action and reaction, Newton third law state that to every action there will be equal and opposite reaction. But this centrifugal force is not a reaction of a centripetal force. Why? Because centripetal and centrifugal force is acting on a same body. But according to Newton's third law, action and reaction is not acting on a same body. Okay, so that's why it is not a reaction force. Now let's see one more example to clarify our doubt related to centripetal force and centrifugal force. For example, we have two boys. One boy is standing outside to see the motion of a circular path, and one boy is inside the circular path, means it is moving with the circular body, it is moving with the stone and a thread. Now carefully see what these two person observe. The outside person observe that as he's saying tension is produced in the string when you are rotating, then centripetal force is there. He's saying centripetal force must be there, only then the string is getting tensed. The string is getting tensed because you are moving. So as you are rotating, string is getting tensed. So that is called centripetal force must be there. So now let's see what next person says. Next person saying tension force, he is also observing that yes, tension force is produced in the string. So he is also feeling that some tension force is there, but along with that he is feeling that one more force is acting which take his stone away from his hand. So now carefully see, he is saying that one more force is acting on his hand which is keeping this body, which is keeping this stone away from him, that is called a centrifugal force. So this centrifugal force is observed by only that person which is rotating with the motion, which is rotating with the body. So here are some two examples related to that, centripetal and centrifugal. But this centrifugal force is not a real force, it is only assumed by the person which is rotating in a circular motion along with the body. So it clarifies the definition that it is not a real force, it is a fictitious force as assumed by the person which is rotating, and it is always acting away from the center. So that's why this boy is saying some force is acting on my hand which take this stone away from me. So that is called centrifugal force. Now this example sums up the entire discussion that centripetal force is a real force which helps the body to rotate in a circular path, and centrifugal force is a fictitious force or non-real force assumed by the person which is rotating with the body, and the person which is not in a motion, which is just see the motion from outside, that person can't feel or see the effect of a centrifugal force. If you like this video, please like and subscribe our YouTube channel. Thank you.